Regardless of which circuit has a problem, troubleshooting electrical problems uses the same equipment and approaches. Voltage, current, and resistance are required in all electrical circuits. The key to good diagnosis is testing for these, measuring them, and comparing your measurements to specifications. To do so, you'll need a firm grasp on these fundamental electrical properties. The electrical pressure that drives electrons to flow when there is a complete channel for them to follow is known as voltage. The rate of electron flow can be described as the aggregate flow of electrons via a wire. The term resistance refers to antagonism to the prevailing flow. To convert electrical energy to light, heat, or movement, an electrical circuit must have resistance. An open, a short, or an extreme voltage drop in an electrical circuit might cause it to perform incorrectly. An open circuit is one in which there is a gap in the continuity of the circuit. On either the insulated or ground side, the open can be found. The resistance of a circuit is reduced when it is shorted. This occurs when a circuit is shorted to another circuit or when a circuit is shorted to ground. One of the circuits is not controlled by its switch when there is a circuit-to-circuit short. The complete parallel circuit will turn on and off with the switch controlling the other circuit because the shorted circuit forms a new parallel leg to the circuit. Many unusual things can happen when dealing with this type of issue. When a circuit is broken, it is said to be shorted. Problems with high resistance might develop anywhere in the circuit. High resistance, on the other hand, has the same effect no matter where it is. Additional or undesirable resistance in series with a circuit will always diminish the circuit's current and the amount of voltage drop caused by the component in the circuit. Circuit defects must be tested. An open, a short, a ground, or an extreme voltage drop in an electrical circuit might cause the circuit to operate incorrectly. Opens are being tested. A voltmeter, DSO, test light, self-powered test light, ohmmeter, or jumper wire can all be used to check for openings. The test equipment utilized will be determined by the circuit being examined and the component's accessibility. Before attempting to figure out what's wrong, the technician must first identify how the circuit should work. The voltmeter readings that should be received in a correctly working parallel circuit are shown in the diagram. The simplest way to test a circuit is to start at the most accessible location and work your way down. Test for voltage at the load's input if the load component is conveniently accessible. To find the open, use the following procedure. The replacement or repair of a damaged conductor is a common part of electrical repairs. Today's technician must be able to read and comprehend electrical diagrams and schematics in order to pinpoint the source of the problem. The schematic should always be the beginning point in diagnosing an electrical system once it has been confirmed that the battery is working properly. The diagnostic method of detecting and identifying the fault source is known as troubleshooting. It's a cause and effect approach to eradication. The technician can figure out how the circuit should function by looking at the diagram. Before attempting to figure out why it isn't working, make sure you have these information. The component locator will aid the technician in locating the electrical components depicted on the schematic. The component finder will frequently include information on connectors, grounds, and splices. The following is the procedure for troubleshooting an electrical issue. Confirm the complaint. Perform a system check to figure out what's going on. Enter diagnostics to receive an issue codes if the defective system is monitored by the onboard computer. Trouble codes are alpha/numeric codes generated by the self-diagnostics program that indicate malfunctioning circuits or components. Concentrate on the electrical schematic. This will show any common circuits. Attempting to work the common circuits will assist with guiding the specialist to the trouble spot. If the common circuits work accurately, the issue is detached to the wiring or parts of the issue framework. In the event that the common circuits don't work, the issue is ordinarily in the power or on the other hand ground circuit. Find and fix the problem. The defect is found by narrowing down the likely causes and obtaining the necessary measurements. Check the ground and power leads before replacing any components. If these are positive, the component is negative. Make a test of the repair. Check the system once more to make sure it's working properly. Electrical wire repair. Not every electrical repair necessitates the removal and replacement of a defective component. A damaged conductor is frequently the source of the problem. The technician must make a circuit repair that does not add to the resistance. It should also be a long-term fix. A damaged wire can be repaired in a variety of ways. The sort of repair employed will be determined by a variety of criteria, including 1. Type of repair required. 2. Ease of access to the damaged area. 3. Type of conductor. 4. Size of wire. 5. Circuit requirements. 6. Manufacturer's recommendations. Wrapping damaged insulation with wire is one of the most popular ways of wire restoration. Soldering, crimping the connections with solderless connectors, and electrical tape or tubing splices. Repairing copper wire. In the automotive, copper wire is the most widely used primary wire. Due to stress or excessive motion, the insulation may deteriorate or the wire may break. Excessive current flow via the wire may potentially cause damage to the wire. Any of these circumstances necessitates the repair of the wire. It may be required to bypass a section of wire that is not accessible in some cases. Cut the cable before it enters the inaccessible region and at the other end when it exits the area in this scenario. Replace the wire with a new one and reroute it to the load component. Use straps, hangers, and grommets to protect the wire if necessary. Solderless connectors and soldering are the two. Crimping. Crimping solderless connectors is a good way to splice wires that won't be exposed to the elements, dirt, corrosion, or extreme movement. In addition, crimped connections should not be used in electronic circuits. A faulty connection or corrosion over time can cause the system's electronic control to malfunction. To make a splice with solderless connections, do the following.